Hi guys, Ms. Burns here. So we're going to talk about section 1.3 today, which is on some applications of linear equations. So before we get too into this, I want to just review some words that you've probably heard in the past when you read a word problem in math class that might indicate that you need to do addition in the problem. So a few that I thought of were sum, total, and comes up a lot, more than, combine, things like that. What are some words you can think of that might mean subtraction when you see a word problem? I think difference is probably the most common. Less than, take away, those come up once in a while too. Multiplication, so some words that might mean multiplication in a word problem. I think product is probably the most common, but you may see something where it says twice a number. That would mean multiply it by 2. Double, of course, would be the same thing. Triple a number. Or of comes up sometimes. And then how about for division? What are some words that might indicate division? I think quotient is probably the most common, but if you hear the word half or divisible, those also mean division as well. Okay, so let's try a question here. It says write an algebraic equation and solve. So they ask you to write it out for the sum of twice a number and 20 is 48. So if we let that number be x, think about what it is they're asking you to add here, the sum of what two things. So twice a number would mean taking the x and multiplying it by 2, and of course means those are the things we're going to add, 20. And then is always code word for equals. So take a look at this and see if this makes sense. So twice a number would be 2x and 20 is 48. So we're going to solve this equation, of course, subtract 20 from both sides, and then divide both sides by 2, and we get a solution of x equals 14. Another example with similar words, but the phrasing is a little bit different. This time it says twice the sum of a number and 20 is 48. So they're asking you to multiply something by 2, twice something. So we're going to multiply something by 2, but what are we multiplying by 2? This time they want us to multiply the sum of what two things? The number and 20. So I'm going to write 2, and then I have to add the x and the 20 together first. So I'm going to put parentheses around that, equals 48. So I'm going to distribute the 2, subtract the 40, and divide by 2. So this time we get a solution of x equals 4. Okay, this one we've got a graph here. It says the graph shows the average number of hours per week that Americans have worked since 1980. It can be modeled by the formula W equals 0.3x plus 46.6, where W represents the hours and x represents the number of years since 1980. So it says when will or did, because it might be past tense here, did Americans work an average of 55 hours per week? So really think about what your two variables represent. W is the number of hours and x is a number of years or time since 1980. So the 55, if I want to solve this problem, the 55 needs to be substituted in for one of those variables. And since 55 is hours, we're going to substitute that in for W. So I've got 55 equals 0.3x plus 46.6. So we're going to solve this equation, subtract 46.6 from both sides, and then take the resulting value and divide it by 0.3, and we get a solution of x equals 28. Now, have we actually answered the question they asked? They said, when will Americans work 55 hours per week? So we've gotten a value of 28. But they want when, so that means they want a year. And remember they said this was measured since 1980, so we're looking at 28 years past 1980, which would put us in 2008. Length of a football field is 2. Okay, let's take a look at example 4. It says you are choosing between two gym memberships. The first gym charges an enrollment fee of $100 plus a monthly fee of $25. The second gym charges an enrollment fee of $50 plus a monthly fee of $35. For how many months will the two gyms cost the same? So let's see if we can come up with an expression to represent the cost for each gym. I'm going to let X be the number of months that you work out at this gym or you have the membership. So for the first gym, we're going to pay an enrollment fee of $100. So that's a flat fee of $100. And then per month, we're going to pay $25. So the cost for the X months would be 25X. For the second gym, we can use the expression 50 because that's the flat enrollment fee plus 35X because it's $35 per month there. And the question says for how many months will the two memberships be the same amount? So if we want the same amount, we want the two expressions to be equal. So I've got 100 plus 25X equals 50 plus 35X. And we need to solve this equation for X. I subtracted 35X from both sides. So I have 100 minus 10X equals 50. And then I'm going to subtract 100 from both sides. So I have negative 10X equals negative 50. And then I'm going to divide by negative 10. And we get a solution of X equals 5. So at the 5-month mark, the two costs for the gyms are going to be exactly the same. 100 feet more than the width. If the perimeter of the field is 1,040 feet, then what are its dimensions? So the first thing I'd probably do is draw a picture for this. We're talking about a football field, so think about the shape of a football field. We'd start out with a rectangle. And if I think about the length, of course, as the long side, the width is the short side. They told me that the length of the field is 200 feet more than the width. So I'm going to give a variable to the width, and I'm going to call that W. And of course, with a rectangle, the opposite sides are congruent. So I've got W on each side. And then if the length is 200 feet more than the width, that's 200 feet more than W. More than, of course, means add. So each length is going to be 200 plus W. Now, perimeter is the length all the way around the football field. Rim, think like the rim around like a fence or something like that. So the perimeter is all the way around the field. So to get the perimeter for any shape, I'm going to add all of the sides together. So I'm going to write an equation where I add all 4 of my sides together, and I'm going to set it equal to the 1,040 they told me for the perimeter. So make sure you see where I've got this, 200 plus W plus 200 plus W for the two lengths, and then W and W for the two widths. So you're just going to combine like terms here and then solve for W. So I'm going to subtract the 400, divide by 4, and I've got a width of 160. Now they asked for the dimensions, so I've got half my answer here. I've got the width. I need to also get the length. And so I'm going to add 200 plus the 160 to get the length, and I get a length of 360 feet. Number 6, it says solve the equation for the indicated variable. So this type of question, this is called a literal equation, where they want us to isolate one of the variables. So they will always tell you what variable to use. This time they want us to isolate for W. So I have the equation 2L plus 2W equals P. We're going to do some rearranging here using algebraic properties. We aren't going to get a number for our answer, though. We're going to get an expression in terms of the other variables. So think about if I want to get the W by itself, it's with this 2W term. That means I need to get the 2L out of my way. I need to get it to the other side. So to get the 2L out of the way, I'm going to subtract 2L to the other side and then write what you have. So now I have 2W equals P minus 2L. And then I'm going to divide both sides by the 2 so that I can isolate the W. This is another way of writing this. The first way in red, of course, would be fine on a test or something like that, but my math lab, sometimes if these questions are multiple choice, they want them written a certain way. So notice to go from this version to this version, I've just separated the numerator. So I've got P over T minus 2L, I'm sorry, P over 2 minus 2L over 2, and that reduces to P over 2 minus L. But either way you write it is fine. Let's try this question. So solve for the variable P. So it's the same type of question. They want us to isolate the P. And what I want you to notice is the variable that we're solving for this time is in 2 terms. We've got P plus PRT. So when the variable you're solving for is part of 2 different terms like that, one technique you can use is to factor. So we're going to factor a P. Think of it like a greatest common factor. We're going to factor a P out of both of those terms on the right side. So we get P and then parentheses 1 plus RT. And then it's the P I'm trying to isolate. So now because the P is multiplying by this expression in the parentheses, to get that expression to the other side, I can divide it. And so when I do that, of course, the 1 plus RT on the right side cancels out, and now I've isolated the P that they were asking me to solve for.